Hey, sixth hour. I apologize I'm not here with you today. I'm in Fargo with the academic Olympic team because they have a competition. So that's where I am. I will be here tomorrow or in the morning if you need me. But we are starting chapter 8, and it's kind of a hodgepodge of like trig, which is exciting, and then we do a little bit of this geometric mean stuff, and we talk about vectors. It's kind of a lot. But this first lesson is, I'll be honest, kind of out there, but it's nothing you guys can't handle, okay? So please be good for Miss Dittis because she is a gem and a half for covering for me today, and help each other out, all right? So we're going to be talking about geometric mean and similarities in right triangles. So geometric mean, okay, well, here we go, is when the means in a proportion are the same. So when we have a proportion, and we use this all last chapter, right? A over B equals C over D. We actually have names for these specific spots. So an extreme are your A and D, so the first and the last. And then your means are your B and your C. And when you have a geometric mean, your means are the same. A way for me to remember which one's my mean and which one's my extremes is that the means are in the middle, which starts with M. Because like when I read this, it's A over B equals C over D. The B and C are in the middle, right, when I say that? So, I don't know, M, middle, means, that's what helps me. But we can do some problems with these, which make our life easier when solving for certain side lengths of similar triangles. So we're just going to practice finding a geometric mean. So we're trying to find the geometric mean of 5 and 45. So I'm going to set up a proportion. So I'm going to have 5 over x equals x over 45. So you see how my x's are my means, and that's what I'm looking for. These guys are the same. So now we're just going to cross multiply and see what happens. So I'm going to get x squared. 5 times 45 is 225. And now we just take the square root. So the square root of 225 is 15. So that's not so bad, right? 12 and 15, so again, 12 over x equals x over 15. Again, it doesn't really matter if you have the 12 or the 15 first, as long as your x's, I suppose, are in your mean spot, you should be good to go. So I'm going to have x squared equals 12 times 15 is 180. Okay, now in your calculator, if you were to take the square root of 180, you'd get a decimal. And in this chapter, they want us to keep it in simplest radical form. So now this is kind of like, did I learn this or did I not learn this last year? I don't know what you learned, right? But we're going to do a little mini lesson quick. So I have to figure out what perfect square evenly goes into 180. So if you need a refresher, your perfect squares would be like 4, 9, 16, 25, 49, 36. Oops, those should be switched. Let's switch those quick. 36, 49, 81, 100, 121. I'll have these written on the board tomorrow so you can see them. But your job is to figure out which one of these, if it's possible, evenly goes into 180. So what I like to do is I like to take 180 divided by 2. And if I take 180 divided by 2, it's 90, right? So I know it's going to be one of these numbers and above. So we're smart people. We can think about things a little bit more logically than other people. I know 81 is not going to go in there evenly. I'm pretty sure 49 is, but again, it's just guessing and checking. So I'm just going to try 36. And a lot of this, you guys, like I said, is just 36. Well, 36 does evenly go into 180. So I'm going to have the square root of 36 equals the square root of 5. Because 5 times 36 is 180, so these are equivalent. And now from here, we just simplify. What's the square root of 36? Well, we know that is 6. Square root of 5 is just square root of 5. There is no whole number. If I totally lost you there, we'll be okay still. But just know we want to have either whole numbers like 15 like we got over here, or we have to simplify our square root. Okay, so this is where that geometric mean will help us find missing lengths. It says write a similarity for the 3 triangles. So first off, do we even see 3 triangles here? I have this red one, right? Then I have this blue one, right? And then I have the big guy. So for me, I like to give myself like a code to follow so I know the order I'm using it. So for me, I'm going to list my long leg first to my hypotenuse. So what am I talking about? Well, if I draw out this big triangle, F, G, E, okay, it's a right triangle, so no matter what, we know we're going to have a hypotenuse, and that is the side across from the right angle, so there's our hypotenuse. And then from here, we're going to typically have a short side or a long side. So if I look here, I can clearly see that EF is my short side, and my FG is the longer side between those 2 legs. So that's kind of how we set up our proportions, by giving ourselves a code, by labeling our sides in that way. So I'll start with that big green triangle. So I'm going to say triangle, and if I want to start with my long leg, well, my long leg we just said was F to G, right? So I'm going to have F, G. Now here's my hypotenuse, so I'm going to have E. It's similar to triangle. So now I'm going to use the blue one. So I have to figure out which is my long leg out of these 3. Well, here's my here's the long, here's the hypotenuse, and here's the short. So I'm going to have H, G, F. And then on our red triangle, if I label here, here's our hypotenuse, here's the short leg, here's the long leg. So if I start with my long, H to F to E. So remember those similarity statements, everything has to match. So this way that kind of helps you guarantee that you are going in the right order. Okay, how we doing? I feel bad I'm not here today. I really do. Because now we're going to use these geometric means and those little codes help us find missing side lengths for the variables. So we have 2 triangles here. We have that red one, and then we have this blue one. So now if I look at the blue one, 4 is what leg of that right triangle? Well, 4 would be the short side, and then Y would be the long side. Now when I look at the red triangle, what is Y? Y is my short side, and 12 would be my long side. So now if I want to find Y, I know I'm going to have to set a proportion of as either short or over long or long over short. It doesn't matter. You just decide, but I know I'm using these 2 legs because I know nothing about the hypotenuse in either of those triangles. So I'm not going to use the hypotenuse at all. So now from here, I'm going to start with the blue one. So if I want short on top, my short is 4. My long is Y, so that's what we label it, is equal to, now what's my short on the red triangle? Well, our short is Y, and our long side is 12. Now, a way to always check yourself is you will always end up taking the same thing times itself if you set it up correctly. So if I cross multiply here, do you guys see how I'm going to get Y times Y? That's an easy way to check to see that you're doing it right. And then 4 times 12 would give me 48. And now from here, we just simplify. So I think we all know the square root of 49 is not, or excuse me, the square root of 48 is not a whole number. So again, here's our quick little list. So does it make sense to go any more than that since I'd be over 48? But again, use your brain. 36 isn't going to go in there evenly. Neither is 25. But does 16? Sure it does. It goes in there evenly 3 times. So now the square root of 16 is just 4. And then we don't know the square root of 3, so we leave it as root 3. There we are. Okay, our next one. A little more complicated because we have 3 variables this time we're solving for. And then it's like, well, geez, how do I know? Do I start with C, D, or E? The easiest one to always find is the middle one. So that's where I'm going to start. I'm going to find E first. So I'm just going to put E to keep my work organized. So if I look, E is in this little left triangle on the left side, or it is in the triangle on the right. So now if I go back and label, E would be the short side on the blue, and 24 is the long side on the blue. Now if I look at the red triangle, 6 is my short side, and E would be my long. Okay? So now from here, we have to set up what proportion we're going to use. Well, again, I'm using the short and long in both triangles, so I'm going to have short over long. Again, it doesn't matter if you put long over short, as long as you're using both of those legs, you're good to go. So now from here, if I start with the red triangle, what's my short leg? Well, I labeled that as 6. My long leg is E, is equal to, now jump to the blue triangle. What is your short side? Your short side is E. Your long side is 24. So again, check yourself. Do I have the same thing being multiplied by itself in either spot? Yep, I'm getting E times E. So I'm going to have E squared is equal to, and then 24 times 6 is 144. And this one works out nice because we know that the square root of 144 is just 12. So that works out quite nice for us. Okay, so now I'm going to erase this top part so I can label. So now from here, it's not so bad. Once you find that first one, we can just do Pythagorean theorem to find the missing 2 sides, right? So if I wanted to find D, here's my right triangle. D would be my hypotenuse. So I'm going to have 6 squared plus 12 squared equals D squared. And now we just kind of crunch those numbers quick. So we'll have 36 plus 144 equals D squared. 36 plus 144 is 180. And we already just looked, right? What did we get on the top of our notes or earlier in our notes? When you take the square root of 180, well, we know that 36 goes in there how many times? Well, 5. So D really ends up being 6 root 5. And then we're going to do the exact same thing for C. So this time, I'm going to find C. We have 12 squared plus 24 squared equals C squared. So 12 squared is 144, and I gotta grab my calculator because I did this a different way, but that's all right. Let's see if we get the same thing. That's the best part about math, right, guys? There's more than one way to do things. Plus 576 equals C squared. Add 144. We are going to get 720. So 720 equals C squared. And now again, it's just guess and check. What perfect square evenly goes into 720? I know that 36 goes into 72, so that might be a good place to start. So I'm going to do 36 divided by, or 720 divided by 36, and I get 20. So now the square root of 36 is 6, but we can still break apart the square root of 20 because what perfect square goes into 20? Well, 4 does. How many times? 5. So now the square root of 4 is 2. Now 6 times 2 is 12, so 12 root 5. Had you tried 720 divided by 144, you would have gotten 5, and that would have been the shortcut from pretty much this step to this one. But it's okay if you can't find the biggest one right away, because in the end you will still get the same answer. It just takes a few more steps. Okay, I bet you are either loving and getting this or you are super confused. We'll try another one and see if that helps us out. Okay, so now on this one, it's questionable as to where we start. Do we find X, Y, or Z? And really, you could probably start anywhere. I guess I just always like to use the middle one first. So I'm going to find X. I want to use this side here. That's in both my two smaller triangles, but that's just my own personal preference. So if I label, X would be my long side, and 12 would be my short side in the red triangle. And if I outline this one on the right, 9 would be my short side, and 12 would be my long side. Another way to check, is 9 less than 12? Yes, yes it is. So we are doing things okay. So now again, do you want to take, it doesn't matter, do you want to do long over short or short over long? I'm just going to do short over long since that's what we've done for the rest of the video. So short over long. So now I'm going to start with my red triangle. What did we label as our short side? We labeled that as 12. Our long side is X. And now I jump to the blue. What's our short side? 9. Our long side is 12. So now we're looking, oh no, I don't have the same thing here and here. 9 is an X, but we still are taking 12 times 12. So as long as you're taking the same thing times itself when you cross multiply, you did it right. So 12 times 12 is 144. 9 times X is 9X. Divide out, and we find that X is 16. We love whole numbers. Yay. Okay. Erase this for us for now. So I'm going to label this as 16. So now from here, it's your choice. Do you want to find Y or Z first? I'm just going to find Y because why not? Y is our hypotenuse of that right triangle, so it's just easy Pythagorean theorem. So 16 squared plus 12 squared equals Y squared. 16 squared is 256 plus 144 is 12 squared. If I add those together, we're going to get 400. Hey folks, we're getting another nice number here because the square root of 400 is 20. Woo. We like that. All right, one more. We're finding Z, and if we notice here, Z is the hypotenuse of that blue right triangle. So I'm going to have 12 squared plus 9 squared equals Z squared. 12 squared is 144. 9 squared is 81. If I add those two together, we get 225 equals X squared, Z squared. And then we take the square root. Square root of 225 is 15. So this one's pretty nice. Okay. Know this, I realize you might be really lost and it's not ideal for me to be gone to not be able to help you on your homework, but think about it, you have 20 other people in your class that can help you. Miss Diz might be able to help you, I'm not sure, she I don't know. She might be able to help you. It's a weird lesson. If not, tomorrow is day 2, so we can try clean up the pieces tomorrow. Just be good, and I will see you tomorrow. Have a wonderful rest of your day. Here's your assignment, 8 through 22 evens. I think you have 3 of these triangle problems, 18, 20, and 22. Try your best, and we'll go from there. See ya.